Hey, welcome back to your favorite intermediate algebra class. We're going to factor quadratic expressions and solve quadratic expressions by factoring. We're also going to find some zeros or x-intercepts of quadratic functions at the end there. So let's take a look at some trinomials first. If you recall, when you were taking two binomials, let's say x plus 2 and x minus 3, okay, we did to multiply these two, we used the method called FOIL, first, outer, inner, and last, FOIL, right? So we went x times x, first, x squared, and then x times negative 3, so minus 3x, and then the 2 times the x, the inner terms, plus 2x, and finally the 2 times the negative 3 minus 6. We combined any like terms we had, and we ended up with negative 3x plus 2x and minus 1x. And we had this x squared minus x minus 6. Well, today when we're factoring, we're going to go backwards. Okay, so we're going to go from the trinomial, in this case anyways, back to the two binomials that are being multiplied. Okay, so when you do that, what I like to think about, let's look at this x squared minus 9x plus 14 here. X squared minus 9x plus 14. So when I'm looking at those two, I say, well, first of all, my first two terms are factors of x squared. And I say, well, that's got to be x and x right there. Okay. So I know those two are factors of the x squared. Okay. Now I'm looking at the 14. I say, well, what are my options for here and for here? Okay, because I know those two question marks, when they multiply, have to give me 14. So I say, well, it could be 2 and 7, or it could be 1 and 14. Okay, so those are my options for the two question marks. Now, the third thing I'm looking at is I'm looking at this sign right there. It's a positive 14, so it's got to either be a positive times another positive to give me a positive 14, or a negative times another negative to give me, because a negative times a negative is still a positive. Okay, so you pick two, and let's say we pick 1 and 14. I say, well, let me go with a positive 1 and positive 14. Positive and a positive. Let's see if this works, and you always check it. Oh, x times x squared, 14 times x, 14x, 1 times x, positive 1x, 1 times 14, positive 14. Combine those. Is that what I started with? And I'm like, nope, that is definitely not what I started with. I started with x squared minus 9x plus 14, so I say, you know what, scratch that. Let's try the 2 and the 7 now, and let's see if that works. Erase my foil over here. So I do it again. I say, well, first ones have got to be x and x. Factors of 14. Let's try 2 and 7. Do you want to go negative, negative, or positive, positive? I say, let me try positive times a positive here. X squared plus the 7x plus the 2x plus the 14. He says, is this what I started with? I'm like, oh, I'm really close. It's not a positive 9x. It's supposed to be a negative 9x. So instead of positive, positive, it's got to be negative, negative. And then you multiply that, and you get x squared minus 7x minus 2x plus 14. Combine your like terms, and you're like, aha, that's what I started with. X squared minus 9x plus 14. So this right there is my factorization. X minus 2 times x minus 7. Okay, that's kind of the idea here when you're factoring these things. Now let's try this 2x squared plus 13x plus 6. I say, well, what are factors of 2x squared? Well, that's got to be 2x and an x, right? And it doesn't matter where the 2x and the x go. I could have those flip-flopped, right? Now I'm going to try factors of 6. I got 1, 6, or 2, 3. Okay, either of those I could try. And I'm looking at that positive again. Since it's a positive 6, I know it's got to be a positive times a positive, or a negative number times another negative number. Okay, so we try it, and we're like, you know what? Let's try 2 and 3, and let's try a positive times a positive, and then we'll go through 2x squared plus 6x plus 2x plus 6. You're like, oh, that's not it. I could flip-flop the 2 and the 3, and then I say, well, that's not it. I try something else. I say, you know what? Let me try 1 and 6 now. Let's see if the 1 and 6 works. I try 1, I try 6, I do it again. 2x times x, 2x squared. 2x times the positive 6, 12x. 1 times x, positive 1x. 1 times 6, positive 6. Compare your like term, combine your like terms. Oh, that's what we started with. Okay, so there is the factorization, the correct factorization. 2x plus 1 times x plus 6. Okay. All right, you also have some special factoring patterns if you recall. So a squared minus b squared would factor into a plus b, a minus b. So anytime you have anything of this form, a squared minus b squared. So for instance, this x squared minus 9, okay, it's kind of like if you want to think about it like this also. So you know it's got to be x, and then you're looking at the factors in 9. You know it's got to be 3 or 1, 9, but in this case, again, it's a special pattern here. Okay, it's a special pattern because you can write it x squared minus 3 squared. Okay, and according to the pattern, you know you're going to have x plus 3 and x minus 3 because if you look at this sign, you know one's got to be positive because positive times a negative is a negative, or it's got to be negative times positive, and it really doesn't matter here. Okay, so you check it, x squared minus 3x plus 3x minus 9. Notice the negative 3x plus 3x, those cancel, don't they? So you just got x squared minus 9. Okay. Let's try another one, a squared minus 81. So you're looking at the a squared, you know it's got to be a and a. You look at 81, and you're like, well, 9 and 9. Okay, look at the negative on that. You know one's got to be a positive times a negative or a negative times a positive. Again, it really doesn't matter here because they're both got an a and they both got a 9. And then you factor it, or you FOIL it just to check it. A squared minus 9a plus 9a minus 81. Negative 9a plus 9a is gone. A squared minus 81 is what we started with. So there it is. A plus 9 times a minus 9. Okay. Let's look at one more of these. 9x squared minus 16. So if you think about this one, this is also a difference of squares. Notice the 9x squared is a perfect square, so is 16. They're both perfect squares. So you think to yourself, well, factors 9x squared, so it's got to be 3x. 3x because it fits this pattern, right? It's got to be 4 and 4. And then you know one's got to be positive, one's got to be negative, and then you check it. 3x times 3x, 9x squared. 3x times the negative 4, negative 12x. 4 times 3x, positive 12x. 4 times negative 4, negative 16. Negative 12x plus 12x are gone. And so there it is, 9x squared minus 16. That's what we started with. So there it is, 3x plus 4, 3x minus 4. Okay. Now let's look at some other trinomials here to factor. Sometimes you can take out and you can kind of simplify your original quadratic. So in this case, you notice I could take a 4 out of each of these. I could take out a 4 of each of these, and that'll kind of simplify things for me. 16x squared minus 8x plus 1. You notice if I distribute the 4 back, I have the original quadratic I was given, right? And now I'm looking at this and I want to factor that. Okay, so I leave the 4 out front, and then I'm just factoring the 16x squared minus 8x plus 1. So I'm like, well, factors the 16x squared. Let's try 4x and 4x. I could try 8x and 2x. I could try 16x and 1x, right? I'm trying factors 1. Well, the only factors of 1 are 1 and 1. Now I look at the positive. Again, it's got to be a positive times a positive, give me a positive 1, or a negative times a negative, give me a positive 1. Okay? And so I'm thinking, well, let's try a negative times a negative, because you notice you got the minus 8x in the middle, right? So that's kind of your hunch here. Go ahead and FOIL it, make sure. 16x squared, negative 4x times 4x times negative 1, negative 4x, negative 1 times 4x, negative 4x, negative 1 times negative 1, positive 1. that gives you that minus 8x in the middle. That's what we're trying to get right there. So 16x squared minus 8x plus 1. Still have the 4 in front. So this, and I would actually rewrite that. You notice that the 4x minus 1, the 4x minus 1, they're the same thing. So I'm going to write it. I have two of those. So 4 times the 4x minus 1 quantity squared. Okay, because I got two of those 4x minus 1s. All right, down here you notice that I can't take anything out of each of those terms, okay? So I'm just going to start going to town on this. So, well, I don't know. Should I try, how about 8y and 2y and factors of 25? How about 5 and 5? I'm looking at the plus. How about plus and plus? And then I start checking. I'm like, 16y squared, 8y times 2y, 8y times 5, 40y, 5 times 2y, 10y, 5 times 5, 25. And you're like, nope, nowhere near. That's 50y. Right? So let's forget that. I could try 1 and 25, but that's not going to get me any closer. So, well, let me try this again. How about 4y, 4y this time? Let me try 5 and 5. Again, I could try 25 and 1 as well here. And let me try a positive times a positive. Give me a positive 25. I'd go on this one, 16y squared. There's a positive 20y. 5 times 4, there's a positive 20y. There's a 25. Combine your like terms. Aha, there it is. So this is my factorization, but you know both of those are again 4y plus 5 times 4y plus 5. So we're going to write this 4y plus 5 quantity squared. Okay. All right, we got some more factoring here. 12x squared minus 3. Let's do this one first. 12x squared minus 3. And notice that there's no 0x term, right? So it's just, this is all we're factoring. So I'm still looking at, can I take something out of each of those? Sure, I can take a 3 out and I can simplify this. 4x squared minus 1. Notice if I distributed the 3 back, I'd still have 12x squared minus 3. Okay, now I factor this thing. Say, well, factors, this is the difference of squares right here. So I know it's got to be 2x, 2x. I'm looking at the 1, 1, and 1. Now it's a negative 1, so one's got to be positive, one's got to be negative. And then I check that. I'm like 4x squared minus 2x plus 2x, those are gone. Minus 1. Aha, there it is. So that works. Okay, let's do b there. 3u squared minus 9u plus 6. I look at each of those terms. Hey, I can take a 3 out of those. Now I'm just factoring this right here. So I know I got a u and a u. Factors of 2 are just 1 and 2. And then I look at the positives. You either got to be positive, positive, or negative, negative. I say, well, let me try a negative times a negative. That's my hunch because of that inner term there. So I go u squared minus 2u minus 1u. Negative 1 times negative 1, positive 2. Combine those. U squared minus 3u plus 2. Is that what I was factoring? Yes, that was what I was factoring right here. So that is the correct factorization. Okay, part C, 7v squared minus 42v. What could I take out of each of those? Well, I could take 7 out, and you notice they both have a v as well. So I would be left with a v right here and a minus 6. Notice if I distributed back 7v squared minus 42v. Okay, now this is completely factored right there. I can't go any further because that's not a quadratic. It's just a v minus 6. And we're trying to factor these into linear terms here. Okay. 2x squared plus 8x plus 2. 2x squared plus 8x plus 2. Okay, taking 2 out of each of those. And you're at this point, and now we're just factoring that. So I'm like, well, let me take out a 2 from each of those. I'm sorry, x and an x from each of those, right? And then I look at the 1 here, and I'm like, well, it's got to be 1 and 1. It's got to be either positive, positive, or negative, negative. And if you notice, if you do this, x squared plus a 1x plus a 1x plus a 1, x squared plus 2x plus 1, and even if I put negative, negative, it'd just be x squared minus 2x plus 1. So you notice I'm stuck. This cannot match x squared plus 4x plus 1. Okay, so I say, well, I'm done. That's as far as I can go right there. And it looks like I can't factor that x squared plus 4x plus 1. Factor it nicely. Okay. All right, let's move on here. Zero product property. Zero product property just says um, if a times b equals 0, if a times b equals 0, well, then either a's got to be 0. You notice that would make it true. Or the b's got to be 0. Either one of those would make it true. Okay, so this comes in handy when we're working and solving quadratic equations. Okay, so if you're solving this, what you want to do is you want to get it one side equal to 0. So the first thing is I'm going to add this 3x both sides. Okay, so 4x squared plus 16x plus 11 equals negative 5. Again, I'm just getting one side equal to 0 here. So I'm putting this thing in standard form. Okay, so one side equal to 0. Okay, put this thing in standard form. Now, right here, now I'm just going to factor. Okay, so let's take a 4 out of each of those. And then now we're factoring that, so I know it's got to be x. If I try factors of 4, I could try 1 and 4. That doesn't work. I could try 2 and 2. That'll work. I'm looking at the sign. It's either a positive times a positive or a negative times a negative. I'm going to try positive times positive. I check that. X squared plus 2x plus 2x plus 4. That's x squared plus 4x plus 4. So that works. Now I apply the zero product property. Okay, so any of these factors that involve an x, I take and I set equal to 0. So x plus 2, if that is equal to 0, that would make the equation true because I would have 4 times a 0 times x plus 2, and guess what? Anything times that 0 would make it equal to 0. Okay, so x plus 2 could be 0, or, and I have another one over here, x plus 2 equals 0. And then I solve each of those. X equals negative 2. And in this case, you got the same thing, don't you? Oops. Subtract 2 both sides here. X equals negative 2. So it's just x equals negative 2 in this case. So we use the zero product property. Okay, let's do another one here. 2x squared plus x plus 3 equals negative 5x plus 19 plus x squared. Get one side equals 0. Okay, so that's gone. Let me add 5x as well. Let me subtract 19 as well. Okay, so it looks like 2x squared minus 1x squared, x plus 5x, 6x, 3 minus 19 minus 16. All of this equals 0. Now I factor this. Okay, so it's got to be xx. I'm looking at that minus 16. I say, well, let me try, how about 2 and 8? And I could try 4, 4, 1, and 16, right? I'm looking at the negative 16, the negative on that. So one's got to be positive, one's got to be negative. So let's go negative times a positive. I check that, x squared plus 8x minus 2x minus 16. Good, that gives me that positive 6x in the middle. So I did factor this thing correctly. So now I just use the zero product property. So x minus 2's got to be equal to 0, or x plus 8's got to be equal to 0. I solve this, add 2 to both sides, there's an answer. Subtract 8 from both sides, there's my other answer. Okay? This also applies when we're finding zeros. What are zeros? Zeros are the same thing as x-intercepts. What do you do to find an x-intercept? You let y be 0, don't you? Okay, so just like when we found x-intercepts before, we're going to let y be 0. And now we can use the zero product property after we factor this thing. So we factor it, set each of those equal to 0, And now we have our x-intercepts, or our zeros. There's 1, 0, there's the other 0. So what this is saying is this quadratic hits at -1, and it's going to hit at -3, okay? So this is kind of what that quadratic's going to look like. So we just found our zeros, okay? We'll see you guys in class. Make sure you bring any questions.